Okay, so there's another way to handle solving quadratics besides completing the square and besides factoring. Now, to be quite honest, this is a shortcut which was developed from completing the square. So, sometimes you guys think, when can algebra ever be useful? Well, what we really want to do is be able to use it to develop kind of formulas that would help us solve something so that we can program technology to do it much faster than we can. And we've done that with quadratics. We've used completing the square. We've worked out the algebra. I can show you a proof, but uh, I'm not going to just because for sake of time. However, I like to do my quadratic formula in two parts. So even though I can write the formula in this box, I'm actually going to do it in two steps, okay? So um, I think it's smarter if you do that. So the first thing we want to find is something called the discriminant, okay? It has a cool word, yes. Discriminant. Yep, okay, good. And that is something that looks like this. B squared minus 4ac. Remember, you got your a, which is in front of your squared term, your b, which is in front of your linear term, and your c, which is your constant term. Well, this is a number. It's just a value, right? Okay, now it goes into the second part of the equation. Okay, and the second part of the equation is where you actually get your solutions from. We want the opposite of b over 2a. Well, that's familiar to us, right? That's the axis of symmetry. Plus or minus another distance we have called the square root of, well, remember that number that we got in the very first part? We put it under that radical and we do it like this. Now, you're never, if you look at a classic textbook, you are not going to see classic textbooks separate this into two parts. Um, but I'm going to highly recommend that you do this in two parts because kids make serious mistakes finding the discriminant and then trying to plug it in. You are also never going to see a classic textbook split it up into two separate fractions like I did, with plus or minus in the middle. But I highly recommend you do that too, because you will have an easier time simplifying and you won't make mistakes. I see way too many kids over the last 30 years who have made serious mistakes when they try to do this. The opposite of b plus or minus the square root of b squared minus 4ac. Oops, that's a bit squeeze. Two squeezed together. Minus 4ac all over 2a. Now, that is the quadratic formula. I get it. But I highly recommend you split it up into two parts and do them separately. Find your discriminant. Now, there are other questions coming in the future that talk about that where you will only need the discriminant and not the second part of the quadratic formula. So that's one of the things I really want you to understand is sometimes a question will only use the discriminant. We'll show you those kind of problems in the future. But right now, I need you to understand that the quadratic formula has two things. Step one, find the discriminant. Step two, plug it into the remaining portion. And I highly recommend you split it into two fractions with a plus or minus in the middle. But one of the requirements, one of the major requirements of these, this is not just a suggestion. This is a requirement. Is it must be set equal to 0 before you begin, and many times they are not. So you have to adjust it so that it is. Now, some of these may factor, but we're practicing our quadratic formula, so we're not going to worry about the factoring right now. So let's see here. We've got first step, b squared. That's a negative 1, right? We got a negative 1. We got a 3, a negative 1, and a negative 4. B squared minus 4 times the a value times the c value. Okay, so that's 1. 12 times 4, that's 48. So This is going to give me 49. That's going to go under the radical. Now, I do want you to realize something before we keep going. When the discriminant, I'll just abbreviate DIS, is a perfect square, we now know it can be factored. That is, if you are questioning whether you can factor something like with the Berry method, you could simply find the discriminant and then it'll tell you whether it's factorable or not. But you got to get a perfect square on your discriminant. Okay, so rest of the quadratic formula. X equals the opposite of B over 2 times A. Well, what's 2 times 3? 6. Plus or minus the square root of 49. Remember, that number goes under the radical, all over that same number 6. Okay? So that's 1 over 6 plus or minus 7 over 6. Now, folks, we can do this. We can figure out what 1 plus 7 is, right? So that's 8 over 6, more commonly referred to on the street as 4/3. Yes, folks, there's street math. And there's 1 minus 7, which is a negative 6 over 6, which is negative 1. Those are the two answers to this question. All right, let's try another one here. Same scenario, got to get this to the other side. X squared plus 6x plus 9 equals 0. So start off with b squared minus 4 times the a value times the c value. Oh, look, the discriminant is 0. That's interesting. So this is going to simplify my work. The opposite of b over 2 times a plus or minus the square root of 0. Well, you and I know that's going to be 0 all over the same number. So really this boils down to this thing right here, because this is not going to do anything. So we get negative 3 as our only answer. This must be one of those parabolas that comes down and touches the x-axis and then leaves it, it bounces off the axis, whereas the other one did not bounce off the axis. It actually cut through the x-axis twice, once at 4/3, once at negative 1. Do we have any more examples on this page? No, we do not. Hold on. So move that over to x squared minus 36x plus 212. Now, I could do the quadratic formula with these numbers right here. It'll give me the exact same answer eventually. But what if I wanted to simplify my life? What if I wanted to factor out a GCF and then look at smaller numbers? That's what I'm going to do. And then my A value is a 1, my B value is a negative 18, and my C value is a 106. So now I can do my B squared. Now you're going to notice every single time I do this, I use parentheses. That's because people make serious mistakes when they don't use parentheses, especially with negative numbers. So if I were you, I would get in the habit of using parentheses so that I don't make mistakes. I mean, even as I'm typing this on a calculator right now, I'm using parentheses to make sure that I don't mess this up. Okay, so I get negative 100. Well, remember this part, that negative 100 is going to go under a radical. That sounds like we're going to get imaginary numbers this time. So we've got the opposite of b over 2 times a plus or minus the square root of, and then this slides under, negative 100 over 2, or 9 plus or minus, oh, wait a sec, what is the square root of negative 100? That's 10i, isn't it? I'm just going to write that right above it just so I know, because I want 10i divided by 2, or 5i, and that's the end of my question. I can't combine those together. We know that that's, we've got two different imaginary or complex number solutions. A complex number, remember, has a real part and an imaginary part. So this one never touches the x-axis, ever. Okay, we'll go to the next slide. Okay, remember it has to be set equal to 0, so we're going to move that term to the other side. That'd be adding an x squared, right? So if I'm adding an x squared to both sides, I now have 3x squared plus 4x minus 2 equals 0. Okay, so b squared. Now this question says give an exact and an approximate solution. So we're gonna give the exact one, and then we're probably gonna have to type this in a calculator to get the decimal, right? So this is gonna be probably a fraction answer, and this one's gonna be a decimal answer. Okay, so we'll do it because that's what it asks for. So b squared minus 4 times a times c. Okay, so I got 40. So we want opposite of b over 2 times a plus or minus square root of 40 over the same denominator, 2 times a. All right, now, remember that square root of 40, right? You're going to be breaking that up into radical 4 and radical 10 because you're looking for that perfect square that can come out. And so now we can simplify this to negative 2/3 plus or minus. So that really would be 2 radical 10 over 6, but I see I can reduce the parts on the outside, so I'm going to make that radical 10 over 3. Okay? Now, another way to write that, which you will see a lot of math teachers do, is this. When you're adding things together that have the same denominator. I don't particularly like that just because kids typically make mistakes, as I said before, when they have it all together. I see lots and lots of mistakes. People reduce one part but not the other, and then they get a wrong answer. But I suggest we leave it like this. Now, what are the approximate solutions? Okay, so I'm literally going to split my screen and go and open up Desmos and show you what I would type. Okay, so let's slide this over. Now, if you have a calculator that does vertical fractions, that's kind of nice. Hit the division key, and then you can just type negative 2 over 3 and come over here, and I got a plus, and another. And then you can actually hit the square root button, or you can type SQR. And as soon as I hit the T, SQRT for square root, it changes to a square root symbol. So since I know that, I typically, oops, not C, I want 3. Okay, so here's one of the decimal approximates. Okay, now, because I want 2 of those, I'm going to copy this, jump down a line, paste it, and change the sign to a minus. So there are my 2 approximate answers to this question. Okay, so I want 0.387, 0.387, and negative 1.721. Okay, those are my approximate solutions. If you are dealing with a scientific calculator that does things horizontally only, I would do it like this: parenthesis negative 2 over 3. Now it's going to have it side by side instead of vertically, but I would use parentheses to make sure that I was doing this correctly. So SQRT 10, jump outside that, divided by 3. It's kind of hard to show on this particular screen because it won't do it, but I would throw parentheses in if your calculator is of the horizontal style. Now, if that's not making sense to you, so it would look more like this on the horizontal style that you were doing division, or maybe it would have a fraction bar again in parentheses, square root 10 divided by 3. So if you're trying to do Wait a doggone second. Not division. What am I doing, man? Let's back that truck up. It's not going to be like that. Can't even listen to myself. No, it's not what I needed. Why is it doing this? Hold on a second. All right, I got her figured out. So I would do something like that, plus. And then, of course, to get the other one, you would change it to a minus. But that's how you would do it on a horizontal style calculator. Okay, so next question. I'll just leave this up since I know I'm going to use it. So I got 2x squared plus 6x. Now I know 2 goes into both of those, but it doesn't go into 7, so I'm not going to mess with trying to factor out a 2. I'm just going to go straight to my discriminant. B squared minus 4 times the a value times the c value, and see what I get there. Let's see here. This minus this, and that would be a negative 20. So I know we're going to get imaginary numbers for this one. Opposite of b over 2 times a plus or minus square root negative 20 over the same thing. And of course, that square root negative 20, we're going to break that up into square root negative 4, square root 5, so that we can have, so this one would be breaking down into negative 3 plus over 2 plus or minus. So that would be 2i radical 5 over 4, but that can be reduced, right? I see this on the outside, so I'm going to have I square root 5 over 2. Now, folks, I'm not going to give some, I don't want decimals for that. Why would they try to? I mean, we can convert that to decimals, but why would I want to? My goodness. It just seems like extra to be extra, you know? I don't know. I mean, we can do negative 3 over 2, right? We know that's negative 1.5. We can do square root 5 divided by 2. We can do that. But what am I gonna write? Negative 1.5 plus or minus 1.118i? Okay. Ugly beside, ugly on top of ugly. So that's my approximate solution. I don't think I would ask for approximate on that. Yeah, it makes more sense when it's a real number and you are trying to figure out where it crosses the x-axis. But since this one doesn't cross the x-axis, it really doesn't make a whole lot of sense to me. All right, let's see what's left. And that's all for today's lesson. Talk to you later.